Good evening. You can see picture of Pascal uh, because on this day only in 1662 rather he was born, and you must have heard about Pascal's triangle, right? We use that for obtaining coefficients in binomial theorem. Those who know about that coefficients of binomial theorem, they must be knowing this. So this is about Pascal. Now, before we again start finding the log values, let me repeat this. Let a raised to x equal to m, where a is greater than 0 and a not equal to 1, then index x is defined as logarithm of m to the base a. See, a, that is base, is positive, not equal to 1. So whatever may be the index, answer m is always positive. So the conclusion is logarithm of only positive number is defined. Log 0 not defined. Log of negative number not defined. Okay. Or you can also say logarithm is the power to which base should be raised. A raised to which number is m? A raised to x is m. That is why log value is x. But log value is the index. Can index be negative? Yes. Can it be positive? Yes. Can it be 0? Yes. So log value can be any real number, but logarithm of only positive number is defined. Usually base of logarithm is 10 or e. If the base is 10, it is called as common logarithm. We are interested in this at present, and it is used in log tables. Okay. Now, in some cases, base of logarithm is e. What is e? E is an irrational number. Its value lies between 2 and 3. And what is the approximate value? 2.7182818. And it is called as natural or Napier's logarithm. And we use natural logarithm in calculus, that is limits, derivatives and integration. Okay. Yes. Can base be 11.2? Yes. Any number which is positive but not equal to 1 can be considered as base of logarithm. I already told you that if you see scientific calculator, there are two buttons. On one button, log is written, that is common logarithm, and on another, ln is written, that is natural logarithm. But now we are interested in common logarithm because we are supposed to discuss log tables. Okay. Then laws of logarithm. Basically, why do we use log tables? Actually, if calculator is available, nobody will use log tables, right? But use of calculator is not allowed in board exam, and that is why we have to study log tables. But for that, you should know rules of logarithm. The first rule is log m into n. It is log m plus log n. See how multiplication is converted into addition. Remember, I have not mentioned the base. It does not mean that baseless logarithm. Whatever is the base on left hand side, same will be the base on right hand side. And as we have decided that we will be considering base of logarithm as 10. That is why I have not mentioned that. Okay. Second rule, logarithm of quotient m upon n is what? It is log m minus log n. So using logarithm, multiplication is converted into addition and division is converted into subtraction. Third rule is very important, logarithm of m raised to n, which is n into log n. See, if I ask you to find, say 1.4 raised to 11, using logarithm, this can be obtained easily. How? Log of 1.4 raised to 11 is 11 log 1.4. Now we have seen how to find logarithm of 1.4, right? So this is how the theorem helps us in simplification. Now you should know that log of any number to the same base is always 1, because logarithm is the power to which base should be raised, right? So log 10 to the base 10 is 1. What is log 1? Log 1 is always 0. Suppose base is 10. Logarithm is the power to which base should be raised. So 10 raised to which number is 1? 0. And that is why log 1 is 0. Is that clear? Now, log value consists of two parts, integral part and fractional part. See, I have uploaded yesterday's lecture also, and before that one more lecture in which I have explained all these things. Okay, so you are supposed to listen to that. Now, each log value consists of two parts, integral part and fractional part. Integral part is called as characteristic, which is written by observation. Fractional part is called as mantissa. Note that mantissa is obtained using log tables. So this by observation, and what about mantissa? Using log tables. Okay, now characteristic, that is integral part, can be positive, negative, 0. One student is asking what is an integer. See, -3, -2, -1, 0, 1, 2, 3, all are integers. So integer can be positive, negative, or 0. 0 is neither negative nor positive. And this fractional part, which is called as mantissa, is always positive, irrespective of characteristic. Okay, and that is why if the characteristic is negative, suppose characteristic is -2, and fractional part is say 0.124, 0.124. So will you write -2.124? No, because this means it is -2 minus 0.124, but fractional part is always positive, and that is why we write this as bar 2.124. This is correct. So this is -2 plus 0.124, because fractional part is always positive. Now we have seen that logarithm of only positive number is defined. So we consider two numbers, rather two types of numbers which are less than 1 and numbers which are greater than 1. Note that when I say less than 1, at the same time it is greater than 0, because logarithm of only positive number is defined. Now I will write number, then char, okay, then mantissa, and final log value. Okay. Now working rule is simple. If the number is less than 1, say 0.213, number is less than 1, characteristic is negative. And how to write that? Characteristic is one more than total number of zeros immediately placed after decimal point. See, after decimal point, not a single zero, that is 0, 0. Add 1 to it, so 1. But characteristic is negative because number is less than 1. Will I write -1? No. Negative characteristic is written through bar notation. So bar 1. Now find the number which is in row 21. Now you will ask me, sir, I cannot see row 0.21 because that row is not there. The first row in log tables is 1, 0. Means while finding logarithm, you have to forget decimal point and zeros if there are any after that. So find the number which is in row 21, because first two numbers, digits rather, they always give row number, and the third one gives column number. So can you tell me the number which is in row 21 and column 3. In this log table, it is 3284. It is 3284. Let me check. Yes, yes, very good. Almost all students have written the same, but see, it is Mantisa, so you should say 0.3284. So what is the final log value? Bar 1.32, sorry, 3284. Is that clear? Good, good. Now I will write another number and you have to write its log value. The second number is 0.1723. The third number 0.083. I will give some time so that you can find the answer. Then 0.00713. I will explain characteristic part. Okay. Number is less than 1. So characteristic is one more than total number of zeros immediately placed after decimal point. There is no zero after decimal point. Add 1 to 0, that is 1. So characteristic is -1, but we write it as bar 1. Here, there is 1 0 immediately placed after decimal point. So 1 plus 1, that is 2. But characteristic -2 is to be written as bar 2. And what about this? 2 zeros immediately placed after decimal point. So characteristic is bar 3. Okay. Now tell me Mantisa and final log value. Good, good. Almost all students have written correct answers. 0.17223, as I said, bar 1. Find the number which is in row 17 and column 2. See, in log tables, it is 2355. To it, add the number which is in the same row, that is 17th row. But column 3 in mean difference section, it is 7. So it comes out to be 0.2362. So what is the final log value? Bar 1.2362. Next, 0.083. There is 1 0 after decimal point. So 1 plus 1, 2. Bar 2. Find the number which is in row 83. You may try to find number which is in row 08. That such row doesn't exist, right? So first row is 1 0, so you have to neglect this 0. So 83, find the number which is in row 83 and column what? 0, because can I write this number as 0.0830? I can. That's it. So that number is 0.9191. So what is the log value? Bar 2.9191. Here, bar 3, find the number which is in row 71 and column 3, it is 8531.8531. So what is the log value? Bar 3.8531. I hope this is clear to you. Now last one. See, yesterday we discussed numbers greater than 1, right? So today I will not discuss those numbers. Tell me 0.0000342. Tell me. I will tell you just characteristic. After decimal point, please do not count this 0 in between decimal point and FSD, first significant digit, which is 3. So 1, 2, 3, 4. 4 plus 1, 5. So bar 5 is nothing but char. Now you have to tell me fractional part. Take your own time. You won't get entry in the classroom once physical classes start if you do not have log tables with you. Okay, yes. find the number which is in row 30 and column 4. To it, add number which is in the same row, that is row number 30, but column 2 in mean difference section, that is what, 3. So 0.4829 and 0.0003. So this is the mantissa. So what is the final log value? Bar 5.4832. Is that clear? Good, good. Now we are in the position to discuss use of log tables. We begin with find 12 into 5. I hope you won't say it is 60. Yes, in fact it is 60, but we have to find the answer using log table. This is simplest sum because this is the first sum on log tables. Okay, but before that, let me tell you this interesting thing. Uh, can you tell me what is 4 cube? It is 64. If I ask you to find the number whose cube is 64, I repeat the question. If I ask you to find the number whose cube is 64, will you say take cube of 64? No, 3 is cube root of 64. This means taking cube or taking cube root rather is the process which is inverse to cubing. Similarly, if log x to the base 10 is say y, then what is x? It is anti-log. It is anti-log of y to the base 10. See, this is common sense. Log x is y. If I ask you to find the number whose log value is y, will you take its log value again? No, it is log of log then. Then you have to consider anti-log of y. And for this, we have to use anti-log tables. Okay, that I'll explain by considering the first example, 12 into 5. Expected answer is what? Obviously, expected answer is 60. Okay, let me explain. Suppose x equal to 12 into 5. Okay, now take logarithm on both the sides. I have not mentioned the base because base is 10 as we are using log tables. What is log mn? It is log m plus log n. Therefore, log x equal to. Now tell me what is log 12. Basically, 12 is a two-digit number. We have done this part in last lecture. It's a two-digit number. Characteristic is one less than total number of digits. So it's a two-digit number. I hope you won't say characteristic is 11. It is not number minus 1. It is number of digits. That is 2 minus 1. That is 1. Now find the number which is in row 12 and column 0. Find the number which is in row 12 and column 0. In my log table, and of course in your log table, it must be the same, 0792. Is it? 0792. Yes, absolutely right. Plus log 5, I write that below the number. Now 5 is a one-digit number. Characteristic is one less. Note that if the number is greater than 1, characteristic is positive, at least non-negative. Now, how to find mantissa? If you try to find the number which is in row 5, you won't get that. Why? Because the first row is headed by 10. So add 0 after this. So find the number which is in row 50, 50 and column 0. So it is 6990. I hope you get the same. Now add this addition as it is. 2 plus 0, 2. 9 plus 9, 18, 1 carry. Then 17, then 7, 1. So addition is 1 point, just check this, 1.7782, right? This is what? This is log x. Listen to me carefully. You can write after this. Therefore, x is what? Anti-log. Anti-log of what? 1.7782. Now listen to me. See, this is characteristic. This is written by observation. It just tells us how many digits are there in the integral part. In fact, characteristic is 1. So there must be 2 digits in the answer. I hope you are getting this. Now see the anti-log table. Anti-log table is different from log table. I hope you have anti-log table with you. Observe that first row is headed by 0.00. Okay. This means you are not supposed to neglect zeros after decimal point. So find the number which is in row 0.77 and column 8, but that in anti-log table. Can you tell me the number which is in row 0.77 and column 8? 0.77 and column 8. 5998. It is what? 5998. To it add the number. To it add the number which is in the same row and column 2 in mean difference section. Same as we did in case of log tables. Okay. So tell me what is that? It is 3. So 5998 plus 3. It is what? 6001. We always get, remember, we always get 4-digit number. Now, this characteristic has role to play. Characteristic is 1. This means there must be 2 digits in the integral part. So you have to put decimal point after 2 digits. Now you will laugh. Sir, 12 into 5 is 60 and you are telling us that it is 60.01. That is why we get approximate value if we use log tables. But that is, see, that is very good approximation. It is almost 60. Is that clear? So this is how we find anti-log. Now, don't write this. Don't write this because we'll be solving difficult sums. Now, I will just write the number and you have to tell me its anti-log value. Okay. Yes, yes, I'm going to explain this again. Don't worry. Oh, I'm sorry. Don't want to see the face of Pascal again. Okay. So, I will write anti-log value, or I will say a number and anti-log. Anti-log of. Okay. Just arbitrarily. 3.14. See, we'll be doing at least 15-20 sums. Don't worry. I am interested in finding anti-log of 3.14. Means this is log value of some number. Initially, we do not consider char. Why? Because characteristic is 3. Why? Because there must be 4 digits in the integral part. That is why char is 3. Simple. So while finding anti-log, we consider fractional part. So find a number which is in row 0.14 and column what? 0, because I can add number of zeros after this. So tell me the number which is in row 0.14. See, many students, they see this in log table only. No, anti-log table. So the number which is in row 0.14 and column 0. You always get 4-digit number. It is, let me explain, 1380. Is it? Are you getting the same? Yes, very good. क्या बात है? Very good. Now, see, now this has role to play, characteristic. See, characteristic is 3. So there must be 4 digits in the integral part. Yes. So the number is 1380. How will you check this? Find out log of this number. See whether this is 3.1400 or not. Just tell me. Log of 1380 must be this. It's a 4-digit number. Characteristic is 3. Find the number. which is in row 13 and column 8 but in log tables, not in anti-log table. See, 13th row and 8th column. Let me check. 13th row and 8th column. It is 1399. Same, almost 0.14. Okay. Yes. Very good. I hope this is clear to you. So anti-log of 3.1400 is what? This. Now, interesting. See, I'm changing what? I'm changing only characteristic. This part remains the same. So you will notice that we get same 4-digit number 1380. Why? Find the number which is in row 0.14 and column 0 1380. Now this has role to play. Characteristic is 1. So there must be 2 digits in the integral part. So decimal point after 2 digits. So if only characteristic changes, position of decimal point changes. Is that clear? One more, one more. See, we are going to solve at least 15-20 sums. Don't worry. Now I'm still changing characteristic. I'm saying it is bar 3.14. Now when we find anti-log, first we have to neglect. I'm not saying forget. Neglect for time being this characteristic. Find the number which is in row 0.14 and column 0 but in anti-log table because we are asked to find anti-log. Okay. So again same 4 digits 1380. Now characteristic is bar 3. So there must be 2 zeros immediately placed after decimal point. So what is the anti-log of bar 3.14? 0.00138. Now you need not write this 0 because it is after decimal point, right? I hope this is clear to you. Now I will write number here. You have to tell me its anti-log value. Say 2.8113. Then I will write bar 1.0007 and the third one it would be 4.1717. I'll give you 2 minutes. Okay, now 2.8113. Find the number which is in row 0.81 and column 1. To it add number which is in the same row, that is 0.81 and column 3 in mean difference section. You always get 4-digit number 7476. Now characteristic is 2. So there must be 3 digits in the integral part. So answer is 747.6. You can cross verify. Log of this number must be this. Somebody was asking me what is the meaning of anti-log. See, logarithm of 747.6 is this. So anti-log of this must be 747.6. Okay. Now bar 1.0007. Find the number which is in row 00.00 and column 0, which is that 1000. To it add the number which is in the same row 0.00 and column 7 in MD section, that is 2. Some students have written 1000 plus 2 is 3000. Come on, it is 1000 plus 2, so 1002. Let me explain. Characteristic is bar 1, so there is no 0. Basically number is less than 1, but there is no 0 immediately placed after decimal point. Okay. Yes. Now, last one, find the number which is in row 0.17 and column 1. To it add the number which is in the same row but column 7 in mean difference section. You get 4-digit number 1485. Now characteristic is 4. So there must be 5 digits in the integral part. So will you write 0 to the left of 1? No, still it is 4-digit number. So you have to write 0 after 5. So this is the number. Okay. Uh, I'm sorry, 2.8113, 0.81, you have to see in anti-lock table, you have to be very careful. So it is 6476 and not this one. This is not correct. This is not correct. Oh, this, what is happening? Come on. Right. Oh, so it is 6476. Okay. Now characteristic is 2. So there must be 3 digits in the integral part. I'm sorry for this. Something went wrong. Now this is correct. Please correct this. What is anti-log of 2.8113? It is 647.6. Is this correct now? Okay. 647.6. Good, good, good. Now this is correct. Okay. Now the last one. Find out anti-log of this. Tell me. Anti-log of 2.0714. Initially, we do not consider characteristic. Find a number which is in row 0.07. To it, add number which is in the same row, but which column? I'm sorry, 0.07 row, first column. To it, add number which is in the same row, that is 0.07, and column 4 in mean difference section. Tell me that 4-digit number. I'm getting 1179. I'm getting 1179 as 4-digit number. Okay. Now characteristic is 2. So there must be how many? 3 digits in the integral part. So what is anti-log of 2.0714? It is 117.9. Now tell me, how will you verify this answer? Try to find log of this. It must be 2.0714. See, 117.9, its log value. There are 3 digits in the integral part, so characteristic is 1 less. So it is 2. Then find a number which is in row 11 and column 7. To it, add number which is in the same row and column 9 in mean difference section. You get this one, 0714. So what is the final answer? 2.0714. Is that clear? Fine. 625 upon 25, but using log tables. Everybody knows that it is 25 square, so answer has to be 25. But let us obtain using log tables. Let x be 625 by 25. Take log. So log x is log of 625 by 25. Log of m upon n is log m minus log n. How to get log 625? It's a 3-digit number. Characteristic is 1 less, so 2. Point, fractional part. Find the number which is in row 62 and column 5, 0.7959. Less, log 25, 2-digit number, carries 1 point. Find the number which is in row 25 and column 0. It is 0.3979. Subtract. So 1.3980. This is log x. Now use common sense. Will you take log of this again? It will be log of log. We need x. But I hope you will not write dividing by log. No. Anti-log. Process which is inverse to taking log. So x is what? Anti-log of. We know that this char decides number of digits. So find the number. Of course, in anti-log table, which is in row 0.39, and column 8, it is always a 4 digit number 2500. Characteristic is 1. So there must be 2 digits in the integral part. Yes, it is 25. Next. Can you tell me cube root of 5 and 2? It is 8. But we have to find this using log tables. Okay. So we begin with let x be, what do you mean by cube root? I already explained that. Raised to 1 upon 3. Cube means raised to 3. Cube root means raised to 1 upon 3. Now take log on both sides. So log x is log of 512 raised to 1 upon 3. We have seen the theorem. Log of m raised to n is n log m. So 1 upon 3 log of 512. Okay. Now tell me log values. Log value rather. It is definitely 2 point something. Now next is cube root of 5 and 2. I have selected 5 and 2 because we know that its cube root is 8. Let us verify the answer using log tables. Let x be cube root of 5 and 2. Right? So log x is log of 5 and 2. Cube root means raised to 1 upon 3. Log of m raised to n is n log m. So 1 upon 3 into log 5 and 2. It's a 3-digit number. Characteristic is 2. So 2 point. Find the number which is in row 51 and column 2. What is that? 0.7093. Now you have to divide this by 3. So this is 0.9031. So what is x? Therefore, x equal to anti-log of 0.9031. Initially, we do not consider characteristic which is 0 because this tells us that there is only 1 digit in the integral part. Remember, when we use anti-log table, we always get 4-digit number, and this char decides the position of decimal point. So find the number in anti-log table which is in row 0.90 and column 3. To it add the number which is in the same row, that is 0.90, and column 1 in mean difference section. If you add, you get 8000. Is this the final answer? No. Characteristic is 0. So there must be only 1 digit in the integral part. Yes. So x is nothing but 8. Yes. 8 is cube root of 5 and 2. Next one, find 34.7 into 1763 upon 81.43 using log tables. Let x be the given number. Use log. Now you have to be very careful. See, basically, actually, I have omitted one step. Let me explain. Log of m upon n is log m, that is log of numerator, minus logarithm of denominator. So minus logarithm of 81.43. But this is product. So what is log mn? If I say this is m, this is n. What is log mn? Log m plus log n. So effectively, what is log x? Log 34.7 plus log 1763 minus log 81.43. First add these two log values, and from the addition subtract this log value. So tell me what is final value of log x. Uh, what is log 34.7? Characteristic is 1. Find the number which is in row 34 and column 7, 0.5403. Now, what is log 1763? Characteristic is 3. Why? Because it's a 4-digit number. Find the number which is in row 17, and column 6. To it, add number which is in the same row, but column 3 in min difference section. So final log value 3.2462. Add with usual method. Now from this, you have to subtract this log value. Characteristic is 1 because 81 is a 2-digit number. Find a number which is in row 81 and column 4. To it, add number which is in the same row and column 3 in min difference section. Subtract. So this is final value of log x. So what is x? Anti-log of 2.8757. This integral part char just tells us that there are 3 digits in the final answer. So initially we do not consider this. Now find the number which is in row 0.87. See, anti-log table, not log table. And column 5. To it, add number which is in the same row. And column 7 in min difference section, you should get this 4-digit number. Now, characteristic is 2. So there must be 3 digits in the integral part. So you have to put decimal point after 3 digits. So what is the final answer? 751.1. Now, before we solve a few more examples, let me tell you this important part. See why addition subtraction is difficult, because if the characteristic is negative, then degree of difficulty increases, because fractional part is always positive. We have never come across such numbers that integer part negative, fractional part positive, right? So let us discuss that. Suppose you are asked to find this. Addition is comparatively easy. Let me explain. If you have any difficulty, you can ask me. What is the addition of these two? Basically, this is bar 2.13 means what? Minus 2 plus 0.13. This is 3.41 means this is positive 3 and this is always positive. See, these are log values. And finally, we have to take anti-log of this. I'm not doing that. I'm just explaining how to add these log values. Okay. As usual, addition. 3 plus 1, 4. 1 plus 4, 5. Now listen to me carefully. This is minus 2. This is plus 3. What is minus 2 plus 3? Minus 2 plus 3 is 1. And that is why this is 1.54. Is that clear? One more. Or in fact, I will write bar 3.81 plus bar 2.91 plus 3.02. Okay, now addition as it is. Addition is comparatively easy. 1 plus 1, 2. 2 plus 2, 4. Now 8 plus 9, 17. 17 plus 0, 17. We write 7 here, 1 carry. Now listen to me. Integral part. This is minus 3 plus minus 2. So minus 5. Minus 5 plus 3 is minus 2. Minus 2 plus 1 carry. Minus 2 plus 1 is minus 1. But can I write minus 1? No, because 0.74 is positive. Fractional part mantissa. So I write this as bar 1.74. Don't worry, I'll explain this again. 1 plus 1, 2. 2 plus 2, 4. 8 plus 9, 17. 7 here, 1 carry means plus 1. When I say 1, plus 1. Already plus 3. So 3 plus 1 plus 4. This is bar 3 plus bar 2. That is bar 5. Bar 5 means minus 5. And this is plus 4. Minus 5 plus 4 is minus 1. But we cannot write minus 1. Because if I say minus 1.74, by that I mean 0.74 is also negative. It is not. So bar 1.74. Okay. Next. Now this is a bit difficult, but After explanation, you will understand it, I'm sure. 3.12 less 4.07. I'm sure you will say, sir, from greater number we subtract smaller and we attach negative sign. Yes, I also know. But we are not supposed to do that. Why? Because fractional part is always positive. Let me explain. We perform subtraction in that order. Means what? 12 minus 7, 5. Okay. Now, from 3, we have to subtract 4. What is 3 minus 4? Minus 1. Am I allowed to write minus 1? No, I have to write bar 1. Now I will show you that how these are the same. Let me explain. Usual method is what? From 4.07, we subtract 3.12. See, 4.07, from greater number we subtract smaller. So this is what? 7 minus 2, 5, 9, 0. But as it is 3.12, final answer is minus 0.95. I hope you know how to subtract. But I have got bar 1.05. These two must be the same. We can check that. Because what is bar 1? Minus 1. And fractional part is always positive. Now tell me, what is minus 1 plus 0.05? Same, minus 0.95. But we do not want answer in this form. This is not wrong. But here, fractional part is negative. We want to write this with positive fractional part. And that is why working rule is perform subtraction as it is. Right? Now last one, then we'll stop. It is bar 1.12 minus bar 3.20. Let me explain first. Now, as it is subtraction, 2 minus 0, 2. Can we subtract 2 from 1? No, we have to take borrow. So, borrowed 1. So, from 11, you have to subtract 2. So, it is 9. Now, listen to me carefully. From bar 1, you have to subtract what? Bar 3 plus this borrowed 1. Now, what is bar 1? Minus 1. Minus, what is bar 3? Minus 3 plus 1 as it is. So, it is minus 1 minus, what is minus 3 plus 1? Minus 2. So, it is minus 1 minus minus plus. So, minus 1 plus 2 is plus 1. So, finally, it is 1.92.